Welcome to Trilinos Tips. Today we'll be talking about navigating the Trilinos source code, and specifically we'll be looking at the Belos linear solvers directory with sparse iterative Krylov solvers and some of the associated tests there. So let's get started. I'm here in my current Trilinos directory, and this is exactly what you get when you clone it from GitHub. If you look in the main directory, you see something like this. Definitely this is kind of intimidating and hard to navigate as a beginner, so we'll walk you through it a little bit. Just as a note, I am on the develop branch, so your code may look a little different if you've checked out the master branch or a different branch. But okay, so as far as this big main source directory goes, the code that most of you will need as beginners will be in packages. So we're going to cd into packages. And looking here, there's a directory named for each package in the Trilinos framework. So you've got a Mesos2, ePetra, tPetra, PyTrilinos, Shilu, etc., etc. So we'll cd into Belos. And within the Belos source directory, you can see there's a source subdirectory and a directory for each linear algebra backend that we support natively in Belos and Trilinos. So there's a directory for ePetra, directory for tPetra, for xPetra, and even one for the more recent Cocos backend. So I'll focus on the tPetra directory because if you are using Trilinos for any task with MPI and distributed linear algebra, and you're a new coder, you're probably working with the tPetra backend. So in the tPetra directory, again, we have an example, a source, and a test. Actually, let me back up 1 second to the main Belos directory, and I'll show you really quickly what's in this source directory here. So in the main Belos source directory, you have your code for what's going on under the hood with each of the Belos linear solvers. So for example, here you can see the Belos multivector traits, some properties for the Belos operator. If I'm looking for specific solvers, there's the solver manager file for the Belos blockgmres solver manager, and this blockgmres iter provides the information about the inner iteration of gmres in Belos. We've got some information about Belos types, some information about orthogonalization managers, right there, some files for status tests, all you would need if you want to know the inner workings of Belos. But as a beginner, that's probably not what you're going for. So like I said, you're probably using a tPetra backend. And let me show you what's in the tPetra directory right here. So like the main Belos directory, the tPetra directory also has a set of source code. So in here are files specific to the Belos tPetra interface. There's the Belos tPetra adapter files that show Belos how to use a tPetra multivector, essentially some Belos tPetra operator interfaces, and some details with registering solver factories. Furthermore, in this directory here, I'll ls these solvers. These are the available tPetra only communication avoiding solvers in Belos. So if you want the source code for those guys, that's again in Belos tPetra source solvers, the solvers directory. But most of you as beginners probably just want a nice Belos tPetra example, and you're not looking to dig into the inner workings of Belos. So for that, your first bet might be to cd into the example file, and we'll see that this looks a little bit sparse. It only has the wrap tPetra solver example, and that's actually probably not what you want as a beginner. That shows something about how to wrap one of these native tPetra solvers into a different type of Belos solver, not really the example that you're probably going to need. So I would suggest go back up to the Belos tPetra directory and go instead to the test directory. And if we look here in the test directory, we can see that there are directories for several different types of Belos solvers. I'll just go to the blockgmres directory as an example. Okay, and here we can see several tests for Belos's blockgmres. This naming looks a little cryptic. test BLF GMRes HB, test BL GMRes HB. So the BL simply stands for block, test block GMRes, and the HB stands for Harwell-Boeing, meaning that this test file is set up to read in a Harwell-Boeing matrix, not a matrix market file, but a Harwell-Boeing matrix, and perform the test on that. And over here we have a test for FGMRes, flexible GMRes. This DF stands for double float. Someone was doing some testing with different precisions. And hybrid GMRes is actually the GMRes polynomial preconditioner or polynomial iteration. So that's the example if you want that. If you're looking for a simple Belos GMRes example, we'll just go to the basic one, test block GMRes HB CPP. And you can skim through this example here. And I'll make a different video specifically walking through all of the pieces in this Belos example, but now you know where to find it. Now, what does this have to do with my build directory? Well, if I switch over, here's my Trilinos build directory. So here's my main folder, and you can see the structure here really mirrors the structure of the main source code directory. So again, we're going to want that packages folder, and I can cd into packages. Again, there's a list of packages. This list is quite a bit smaller than the list of packages in my main source directory. That's because when the code is compiled, you only end up with folders for the packages that you've enabled. So there are fewer folders here because I simply haven't enabled every package that's available in Trilinos. But I did enable Belos, and so there's the Belos package, our linear solvers, we'll go there. And again, there's a source directory and a tpetra directory. We want the tpetra directory. And as I said before, we'll go look at the tests. And then we'll go to the block GMRes again. And if you see, the .cpp files that I had in the corresponding directory in the source code have now been turned into executables. So I can actually run these executables. Let's see, Belos tpetra block GMRes HB. Remember the HB stands for Harwell-Boeing. And here in our executable directory, here's the bcssTK14.hb, the Harwell-Boeing formatted matrix that we're actually going to read in for our test. Okay, let's run this test, see what happens. And the test runs, but we don't get a whole lot of output. So I will add parameter for verbosity, add -- verbose, run it again. And this time we actually get some output. So again, I'll go over this in more detail in a later video, but we can see that our solver converged in 276 iterations. The ending residual norm was about 9.89 times 10e to the 6, and the total solve time was about 2.8 seconds. If you want to look at more parameters here, you can always add the -- help argument. And you'll see there's more parameters you can mess with. The residual tolerance, you could read in a different matrix file name, change the number of right-hand sides, etc., etc. And again, those correspond to the files that we saw in the upper level directory. Really quickly, so I'm back in the source code directory, not my build directory, and I'm back in the tpetra test directory. Let me show you the tests for the block CG solvers. That's another common one. Okay, so again, the BL stands for block. This one must be doing some tests with a complex valued matrix. This one tests the pseudo block CG solver. Here's one for pseudo block stochastic CG, and so on and so forth. And you can go up and see tests for other solvers such as GCR ODR, RCG, recycling CG, TFQMR. Or for those native communication avoiding solvers, that's what this native folder is for. You can see what examples are there. And yes, here's your basic understanding of how to navigate the Belos Trilinos source directory. Thank you for coming to Trilinos Tips. Next time we'll try to show you around a few more other packages in the Trilinos source code. Have a great day.